Hello everyone, welcome to my channel Middleware Technologies. Today we will be looking at a very important topic, that is HTTP caching. So here in this video, we will try to see how we can cache static content in Apache HTTP server for performance optimization. So here in this article, we are basically going to build some static content. We will be deploying it onto the HTTP server, and we will be enabling or we will be checking about the enabled modules which will help us with the caching technology, and we will see how caching can improve our performance of the application. So coming to my test environment, I have a Fedora server on top of which HTTPD with the following version is installed. So let us understand what is caching. What is HTTP caching? HTTP caching is used to store responses associated with requests and reuse the stored responses for subsequent requests. So basically, in a client server model, when a request is sent from the client to the server, a response is served. That is ideal scenario, but this response can be stored in a caching technology, and it can be reutilized for further requests that are coming from a client for a resource on the server. So that is what caching is all about. So let us try to understand about the key components, that is key components of HTTP caching. So first one is cache. Cache, as I said, it is a storage location that can reside in a browser or in a proxy server or in a content delivery network where the cached data is kept. So these are the three major locations which we can say wherein caching can happen. Browser is basically holding the private content specific to the client, and proxy servers are basically intermediate servers in between the client and server which are holding the static resources. So proxy servers are where the developer or the application developer, we can say, or the service developer does not have a control. But CDNs are different. CDN, as I said, content delivery network, are where the cached content of the resources can be kept, and they are in complete control of the service provider or service developer. Now let us try to understand about cache control headers. So in order to use the cache technology, we need to use a set of cache control headers. These are instructions that are sent by the server to define how and for how long the resources should be cached. So that is how we define, we use a set of control headers which will help us in defining how and for how long the resources can be kept in a cached technology or cached location. Now let us try to understand about expiration and validation. So this is a mechanism to ensure that the cached data is fresh and valid. So basically, whatever the data or the resources that we are caching, we need to understand or we need to analyze whether that data is fresh or stale. So that is what expiration and validation will help us in understanding about our data. So now that we have understood about the key components of HTTP caching, let us try to understand about the advantages of HTTP caching. So the first one is improved performance. So this reduces the time needed to load a web page by serving the cached data instead of fetching it from the server. So one important factor about HTTP caching is it improves your performance or the performance of the site. Basically, a site consists of a large amount of static content like images, JavaScripts, and HTML. And these data, some of the pages, they never change over a time period of for some years. So these data or this content can be stored in a cache technology, and they can be reused by a client who is trying to access the website. So cache technology is something which is going to stay in between the client server model, or it is going to stay nearby to the client wherever he is located. So it will basically improve the performance of the application. Basically, it provides a good user experience to the client. Coming to the next benefit, it is redirect bandwidth usage. No, it is reduced bandwidth usage. So it basically, if there is a cache in between the client and server, the bandwidth, the utilization of the network bandwidth is going to be drastically reduced. So everything is not going to be every request is not going to go into the network, and it is ultimately going into the server, but there are some requests that are getting served by the cache, limiting the network usage. So that is another benefit. So the third benefit is reduced server load. So this is where the requests, when they are getting when a client is trying to request for a resource, it will be first looked into the cache storage, and if it is present, it is going to be served from that cache instead of going to the server. So it will reduce the traffic on the server, and at the same time the server is not going to process any of such requests, so the load on the server is going to be reduced. So that is the another benefit of HTTP caching. And the fourth one is better user experience. So ultimately, like all these performance and reduced network usage and reduced server load is going to ultimately boost the user experience. That is, it will produce a faster page load times, improving the overall experience of the user. Now let us try to understand about the types of caches. So as per the HTTP specifications, there are two types of caches. One is private cache, which is which is kept in the browser cache itself. So this is basically is used to provide personalized content for a particular client. So let's say if a user is trying to search for a specific thing over a time period of an application usage, so that application will understand that this user has a preference of trying to look at these things. So that page is going to be served by default based on the user's search results and whatever it has been cached in his private browser cache. So that is what private cache is all about. The other cache is, as I said, it is a shared cache. So shared cache is something that is lying in between the client and the server, and that can be further divided into two types, that is proxy cache and managed cache. So proxy cache is something which is intermediate server that is trying to cache the results of the server or the response, and it is kept in between the client and server, but the service developer does not have a control on the proxy caches. The other one is managed cache. So managed caches are also intermediate caches that are kept in between the client and the server, but they are in complete control of the service developer. So they can they have dashboards or administrative utilities with which they can control the caching content. They can refresh the caching content, and they can administer it completely. So that is what managed cache is all about. So we have understood about private cache. This is basically to use it to store the personalized content about the client. And proxy cache, as I said, it is an intermediate cache that acts like a managed cache. So proxy cache and managed cache are both caching technologies or strategies used to improve the website performance and reduce the traffic load on the origin servers. Proxy cache. So as I said, they are used uh, usually implemented by intermediate servers that store copies of freshly accessed web content. And managed cache, they are explicitly deployed by developers to offload the origin server and deliver content efficiently, often using specific caching technology. So this is basically managed caches are technologies that are deployed in between the client and server to offload the origin server and deliver content efficiently. So now that we have understood about the different caching technologies, let us understand about the cache control directives. So there are some important directives or the headers which we send in a request or response, which play a very important role in how and how long the caching of the resources is going to happen, and like how these cache resources will be validated. So there are some directives that we need to understand in order to like implement the caching technology efficiently. So HTTP caching behavior is controlled using the headers such as cache control. So this is very important header which specifies the caching rules. Example, like no cache. So it is going to not it is not so this basically tells not to the user not to use cache. And the other one is no store. So basically it is telling the client not to store anything in the cache. And maxage is basically telling how long the cache is valid. And the next important directive is expires. So basically it is going to hold the date when the cache resource is going to expire. So there are few what we say the HTTP headers which are used in HTTP's 1.0 specifications, but they are going to be deprecated, or they are going to be replaced with some important some new headers which are a part of HTTP 1.1 specifications, and they are going to take precedence over 1.0 specification if both are present, and expires is one of them. So it is basically a directive that has been provided by 1.0 specification, but that is going to override over the time by 1.1 specification like maxage. And we have another important directive, that is ETAG, that is also a part of HTTP 1.1 specifications. So this basically helps in validating whether the cached version is still up to date. So ETAG is basically a hash value that is calculated about a particular page. So let's say if you have an index.html page that is accessed using a particular protocol and particular port and particular host. So it is going to calculate a tag value based on all these values or all these parameters of a page, and it is going to assign an e tag. So over the time, if that page is going to change, let's say the page content has changed, or the page serving protocol page on which it is served, like the protocol has been changed, so the e tag value is going to be changed, or the hash value is going to be changing accordingly, and based on that e tag value differences, the caching validation is going to happen. So that is what e tag is all about. And last modified, it is also the same thing as similar to as e tag. It indicates the last time the resource was modified. But this is a very important directive that is a part of I think 1.0 specification, but it is still going to need to be present in your S3 web headers. So basically, in order to mention like how or when the page was last modified, and it is going to be utilized in other like domains also, like the CMS domains also, to know whether when the page was last modified, and they are you use it for other purposes. So now that we have understood about the different important directives, if you want to understand about more about HTTP caching, like you can just go to the following page. So this is a very good instruction or information I can say about the HTTP caching, which will help you understand about the different caching technologies and different strategies that can be used in different situations of a client server model, and what are the different directives that are a part of HTTP 1.1 specification and a part of 1.0 specification, and importance of those directives in a particular strategy that you are going to utilize in your caching technology. So now that we have a good picture about what is caching, what are its advantages, and what what are the different directives that we can use in order to implement caching uh, in our application, let us try to understand about a high level architecture that we are going to implement in this demo. So here, like, we are not going to go in depth about the HTTP caching, but we are going to see like how we can enable HTTP caching to disk in Apache HTTP server. So as you can say, so this is my Apache HTTP server, wherein like I have a HTTPD process that is running, and it is going to leverage the disk cache technology, or mod underscore cache underscore disk module, specifically if I can say, to cache the resources or the static content to disk. And let's say if that cache is not available in the disk cache, the HTTP process is going to process that request, and it is going to serve that content from the document root, that is the location, or that is the location of the file system from where the static content is going to be served for the request. And this is our client who is going to access the static resource that is either going to be served from the disk cache or from the file system. So this is what, like, our basic setup is going to be there, and we are not going to go in depth in configuring the website or the configuration for a particular context of the web application, but we are going to do some basic setup so that we understand what is caching and where it is getting logged, and how we can utilize that information to troubleshoot any issues. Now that we have understood about the high level architecture, let us go into our procedure to implement caching in Apache HTTP server. So as a first step, we need to ensure that the Apache HTTP server is installed and running. So first thing, we can check whether the package is installed on our server. So this is the package that I have currently installed on my machine, and as soon as the package is installed on your Fedora operating system or any Linux operating system, it should ideally start up your HTTP process also. So that thing you can verify using sudo systemctl status HTTP service. So my HTTP service is up and running. So let me clear my screen. So first step is verified. Like, we have Apache HTTP server installed and running. Now let us go to our next step, that is step 2. Ensure that the mod underscore cache module and some other related modules which we are going to use are loaded. So the default HTTP package installation on Fedora 41 OS loads the mod underscore cache module from the following configuration. So this can be verified using the following command. So here basically like we are going to get the following configuration, that is base configuration, which holds all the modules that are loaded by default, and from that we are trying to just grep for mod underscore cache to see like what are the cache dynamic modules that are loaded as a part of HTTP process by default. So as you can see, there are three modules. The mod underscore cache is going to be the base module for all the caching implementation that we are going to use as a part of Apache HTTP server. And mod underscore cache underscore disk is specific strategy that we are going to use in order to store our cache into a specific location on the disk, and that is what we are going to use in this demo. Mod underscore SO cache is something related to static object cache, which we are not looking in this demo. Maybe we'll try to look at it in another demo, but these are the two modules which we are going to use for this demo. So now that we have looked at the base configuration and seen like what modules are by default loaded as a part of this HTTP process startup, let us try to validate like what are the what dynamic modules are loaded by running the below command. So now that we have our HTTP process running, we can check what are the modules that are loaded in our server. So it is possible that the configuration is there for a particular module to be loaded, but that configuration has been not included in the main config file, so it is possible that that module is not loaded. So ideally, if you want to check if your cache modules are loaded, is using httpd -m. So you can see like we have three modules that are loaded, that is mod underscore cache, mod underscore disk underscore cache, mod underscore SO cache underscore cache. So these are the three modules that are by default loaded, and we are going to use the first two ones for this demo. Now let us go to our next step, that is create and update the configuration file. So here like what we are going to do is we are going to create a new file, that is cachedemo.conf file, which will be present in the default location of the HTTPD configuration, that is etc httpd config.d, which is by default included in the default httpd.conf configuration file. So this configuration is basically will suggest HTTPD service to cache any static content under the root context, that is slash, and also any static images and JavaScript files under /image and /js context. So let's try to understand about this one. So if you are building a static content, the web structure is going to be like there will be a root folder under which we will be having images folder, let's say, which will hold all the images, and let's say in the root folder we have JS folder under which we will hold all the JavaScript files, and let's say like we have CSS content also, so we will be holding that CSS content in a separate CSS folder. So this is how a basic static content is structured. And if you want to what we say cache all this static content, we need to know where that static content is located. So we need to make sure that this static content is located within defined folders such as /image or /js, so that your caching implementation or the caching implementation is going to be easy. Okay, so that is why it is important that you have a structured website content. The cache data is stored at the location specified by cache root directive. So this is important directive that we are going to use as a part of this configuration, which will provide the location where the cached resources are going to be stored. Let us see like that file. So I have that file already created, so let me show you. So as I said, like it is located in the following location. So let me cat this file. So this is cache root wherein the cached content is going to be stored. So you need to ensure that the following location is present on your server and it is accessible by the server. So let's say if your server or the HTTP process is running using the Apache user, this location should be having permissions or ownership of Apache, so that the Apache process is allowed to write into this location. So that is very important, and this location needs to be present before you start using the caching technology. And this is cache enable. Like this directive tells like we want to use the disk strategy in order to store our cached resources, and this is the HTTP string, or basically the URL which we want to cache. And these are some other directives like cache directory levels and cache directory lengths. So cache directory levels is basically telling like how depth we want the cache root directory to have the content stored. So we will take a look at it when we try to create a cache, like how this two-level directories gets created. And this is cache directory length. Basically we'll try to understand what are these two directives when we try to actually do the caching. So that's when like we will you will get a clear picture of these two directives. And here like you will see that basically like we are keeping this cache enable disk in a particular location directive to tell the server that we want to cache all this root resources to disk. And similarly like we want to cache all the images like which are served using the slash images context to disk, and for JS also this is same. Okay, so this is very basic thing that we are using to understand like how caching technology can be enabled in the Apache HTTP server, and how we can log how we can see which type of content we want to cache. So this is one file config file that we are going to that we need to create as a part of this demo. And also as I said, like we need to ensure that the following location or the cache storage location is created, and it has a ownership of Apache Apache if the Apache server is running with the following user. So once both of these are done, like we need to we will be updating we can update the log format for the access logs. So for that, like first we need to know, so let me show you that file etc http.conf conf and http.conf file. This is our main configuration file. In that you can try to grep for log format. So we have modified one line in this location. So you can see like in this log format I have appended this field that is cache status. So this is basically going to tell us whether the Apache HTTP server is serving the content from a cache or from a disk or the file system of the document root. So this is what like I have modified. So by default like we have all this in the combined log format, but I have just appended this field in order to log the caching status. So this is what like we need to change as a part of this demo. So we have created this cache demo.conf file to like tell like what we need to cache, where we need to cache, and how we need to cache. And once that is done, we have created this location where we want to cache that resources. And once all both of that are done, we need to update our http.conf file to enable logging of the cache status. So this is what the configuration is all about. Now let us try to go to our next step, that is step 4, upload static content. So here, like, you can use any web static content which has a root directory under which we have images folder and JavaScript folder and CSS folders, which are basically going to hold that specific content. So images is going to like hold your images, Java JS folder is going to hold your JavaScript, and CSS is going to hold your all your styling data or styling files. So for this demo, like what I did is I just cloned this. So let me first go to sudo root, do a sudo su dash to get into root, and go to folder var www html. This is the document root where we will be serving the static content. And here, like, I'm just going to do a git clone of the following site of the following project. So this is basically getting started static content project in GitHub for Mozilla. So once that static content is cloned, like, it is going to clone it into the following location, but we will just get all that content into the following root location. So let us move all the content from that folder into the root location and remove that folder. So we will just use this static content for this demo. So now you will see that all the static content is present over in this location. So we have images folder, we have styles. Basically it is going to hold the style sheets. So the important thing is, like, we are going to see like how caching affects accessing this index.html page, and also we will see like how it affects the images that are going to be accessed using the caching technology. Now let me clear my screen. So we have our static content ready in step 4. Now let us go to our next step, that is step 5, restart HTTP service. So now that we have our configuration ready and we have our static content ready, it is time to restart our HTTP service. So let me restart my HTTP service. So now my HTTP service is restarted. Now let us go to our next step and the final step, that is step 6, validating the cache results. Okay, so here so as I said, like, we are going to use a very basic demo in order to see like how we can do caching, and like we will see like how the caching is stored in Apache HTTP server if we are using the mod_cache_disk strategy, and how we can log that information. Okay, so that is all we are doing, and we are not doing any configuration on the server side, which will like append cache headers such as cache control in order to like tell the client like how and how long the cache is valid. So that we are not doing explicitly on the server side, but we are going to demo it. We are going to use that directives from the client end by forcing from the client end onto the server, and see how it affects the cache cache technology. So here, like, we will try to access the index.html by setting the cache control header with the directive max age 30. So basically, like, we are going to access the index.html from the client side by setting the cache control header, which states that the max age of the cached resource should be 30 seconds. So if the content is basically over 30 seconds it is going to be like stale. So that cache is going to be stale, and we will see like how Apache HTTP server is going to revalidate that cache. It is going to revalidate by by the cache service by sending a conditional request. So we will see like how Apache HTTP server is going to send a conditional request to the origin server to asking whether the resource has been updated since the last cache results. So this is what basically like we are going to try to see in this demo. So now let me copy this command, and here so you can run it from any server or any remote server, but let us try to run it from the same server. That is also fine. So here like what I'm going to do is I'm going to set the so let's see let's set the max age as 10, so that the cache results is going to be valid for 10 seconds, and let us try to run it for let's say 50 iterations to access this page, that is index.html. And now let us on the other server let us try to tail the logs for Apache HTTP server. So here like we are going to tail the access logs. So let's say we are going to tail the access logs over here, and we will see like how this request is going to affect the caching technology that we are using, and how Apache is going to do the request processing. So we have started the requests. So you'll see the first hit for the index.html is cache miss. So basically there is no cache which is going to present for index.html, so that there is a cache miss, and this is going to run for I think 50 iterations if I'm not wrong. So let us see like let us wait for it to complete for 50 iterations, and then we will try to get an understanding of this log. So now our 50 iterations are completed. Okay, so let us try to understand the log first. So as I said, the first hit for the index.html is a cache miss. So this is the log that you will get: cache miss attempting entity save. So it is basically going to start caching the index.html page that is present in the root location of the document root, and the further requests. So the further request until the 9 requests are done, they are going to be served from the cache. So that is why the cache hit is success. So this is all the requests that are served from the cache. And once the 10 seconds have been completed, the max age that we have set when we try to trigger this client request. So we have set the max age. So once the 10 seconds has been completed, again the Apache HTTP server is needs to revalidate the cache results. So basically it will need to so the max age has been expired, so the 30 seconds has 10 seconds has expired, and the cache results which are present in the cache storage are basically stale. So it needs to send a conditional request to the origin server and ask whether this page is still the same or changed. So based on that result, so if it is not changed, it is going to update its cache cache status, so that it is again fresh. So here, like you can see, that entity has been refreshed because there is no change in the index.html page. So it is going to get a results of nothing has been modified on the server layer, and the cache is going to just refresh uh, that entry of that index.html as fresh, and again it is going to hit for another 10 hits. It is going to be served from the cache hit, and after that it is again going to revalidate that cache. So this is how, like, we are controlling the caching uh, resources so that it is valid only for 10 seconds. So now we have understood like how we have used the cache control max age. Now let us try to hit the same page index.html using no cache. So no cache directive is basically going to tell the server that it is not willing to, the client is not willing to use the resource from cache. So the server needs to always try to like pull or get the resource from the file system directly, rather than getting it from the cache location. So this is what the cache control will tell the server. So these two directives, like we are, as I said, like we are doing this demo from a client side. So we are like forcefully controlling how the caching is going to, like how the caching is going to happen uh, on the server side using this cache control directives. But ideally in a production environment, like these directives needs to be like configured on the server level, so that whenever a client request is sent for a particular resource, and these directives are these headers are going to be served, cache control headers are going to be served as a part of response, and they are going to control like how the caching is going to be done for a particular resource, and how often that cache is going to be needs to be revalidated or reutilized. So now let us try to hit the same page using cache control as no cache. So let me again try to first tail the logs. So here, like, this is going to be the new requests, 50 requests. So 50 requests is not needed for this demo, but let us try to do it for 20 requests. So now you'll see that every request is a cache miss. So there is nothing getting served from the cache. So everything is going to the server, and it is going to be served from the backend file system, that is the document root for our root context. So all the 20 requests are served, and you can see it is a cache miss. And now that we have seen like how cache is utilized, and like we have also seen like how the cache is getting logged, so we are able to see like whether the cache is a hit or a cache is a miss. Let us try to see the location where the caching is actually happening. So as you know, like we had set a directive in the configuration, that is cache root. So cache root was set to var cache apache. So this is where our cache is located. So you will see that there is a directory called R. So let us try to see this location directory structure. So you'll see there is a 2-level directory that has been created, and in that, like, you will see the headers and the data. So this is where the caching is going to be happening. And so as I said, like we need to understand about the two directives that are cache dir level and cache dir length. Okay, so as I said, cache root is the directory root under which the caches are stored. Cache enable enables caching of specified URLs using a specific storage manager. So that is what cache enable is And cache dir levels, this is the number of levels of subdirectories in the cache. So this is basically we are setting it to 2, and cache dir length is the number of characters in the subdirectory name. So if you want to look at this in more details, let us go to this page. So now let us try to understand about the cache dir length directive. So cache dir length directive sets the number of characters for each subdirectory name in the cache hierarchy. So as we have set this to 1, so if you see this directory structure in the cache location, so it has created a directory with only one character. So that is what the cache directive directory length directive is going to do in the caching strategy. And also, like, it can be used in conjunction with the cache dir levels to determine the appropriate structure of your cache hierarchy. So let us try to understand about this one. So cache directory length, so we have set it to 1. So there is a directory that is been created with only one character. And cache dir levels, we have set it to 2. So it is going to create a 2 levels of subdirectories. So cache dir level directory sets the number of subdirectory levels in the cache. So in our case, it is going to be 2 subdirectories. So this is what the 2 subdirectories have been created with only one character for directory length. So this is what basically a high value of cache directory length. So basically, if the directory name is high with a high value combined with a low value for directory levels, it is going to create a flat hierarchy in the cache location. So that is what it is all about. And if we have a high value of cache dir level, so let's say we are creating subdirectories with high number of value. So let's say if if we have set it to 10, so there will be 10 subdirectories that will be created under our cache root. And the cache dir length, so let's say if we are setting it to value with low value, so let's say if we are setting it to like 1 or 2 characters for the dir, it is going to create that 2 character dir in that deeper level directory structure, making it a deep hierarchy with a small number of subdirectories at each level. So each directory that is going to be created, that is going to have only 2 characters. So once that directory is created, it is going to create another directory. So the larger the value of the directory length, the flatter the directory structure you are going to get. So that is what these 2 directories will help you in making your directory structure look like a flat directory structure or a deeper hierarchy directory structure. So that is what we wanted to see, like in this demo, like how we can do the configuration in the Apache HTTPD server to carry out the caching at the disk level, and how we can see the results of those caching using the configuration on the logging side. And we have seen like only few directories, like let's say maxage and no cache in the cache control, that will help us in making like how the caching is going to be controlled. But there are, as I said, like there are other directives that we can utilize in order to implement our caching strategy in a much better way, based on what type of static content we have, and what are our contexts, or what are our application URLs that we are going to use in order to access our application. So this is HTTP caching, as I mentioned in my video previously. This is going to be a very important asset to you to understand more about the HTTP caching and understand about the different directives like cache control, which will do personalized caching in the browser. And so there are different directives that are given over here and explained far better to help you understand like what all these directives will do in your environment if they are getting utilized, and what are the implications of that. So this is a very good guide for understanding the basics of HTTP caching. And once you have a good understanding of this HTTP caching uh, technology, like you will be able to implement it better on whatever HTTP web server that you use in order to serve the static content in a better way. So that is what I wanted to show you in this video. Thank you all. Thanks for watching this video, and you guys have a great day.